Going on to the last topic we are covering, we're skipping section 3 in chapter 2. We're going to deal with linear inequalities now. And the key to all of this, of course, is the inequality symbol. This one is less than. This one is greater than, reading it from left to right. And then we modify this one by saying less than or equal to, greater than or equal to. And then a little later we'll also take a look at absolute values and inequalities. Now generally when we are dealing with inequalities, to solve them we're going to use the very same techniques that we use to solve equations. There's one exception, and they're pointing it out here, so let me go over it too. If we say that 2 is less than 4, that's a true statement. And if we multiply this 2, this side of the inequality, by 2, and this side of the inequality by 2, we get 4 is less than 8. And that is still true. But if we multiplied each side of the inequality by a negative 2, then this is a negative 4, this is a negative 8, and negative 4 is not less than negative 8. So the thing to pick up here is if you multiply or divide an inequality by a negative, to keep it a true statement, you must reverse the direction of your inequality sign. And that's what they're describing here. So that's the one major difference. If you multiply or divide an inequality by a negative, you have to reverse the inequality sign to keep it a true statement. So in example 1, we have an inequality. To solve it, we want to isolate the x, so we will subtract 5 from both sides, and we get 3x is greater than 6. And then to solve, we're going to divide both sides by 3. This cancels out, and we get x is less than 2. Now, one of the main things we're going to do here is do what we call a graph of our inequality. And when we do a graph, we take the number that we're interested in this case it's a 2, and it says here that x is greater than 2. Now in old days, high school perhaps, if you were going to graph that, and they said that x is greater than 2, 2 is not included in the set, and you would indicate that by putting a little hollow over the 2, and then greater than is to the right, so we would make a line like so, and that would be the graph. Well, in our math book, instead of using a hollow to indicate the 2 is not included in the set, we use a parenthesis, and then that goes to the right like so. Now we're also going to use what is called interval notation. And interval notation starts at 2. And since 2 is not included in the set, we put a parenthesis, just as we would on the graph, comma, and this is going out here to positive infinity, and that's how we would do it. So we solve it in the typical way we would solve an equation. We didn't have to divide by a negative here, or multiply by a negative, so we don't have to reverse the inequality sign. And then once we made a graph of it, we could make interval notation right from the graph. Now as we do example 2, and they're showing you the steps, and you're getting to this step. Now notice you have a negative 5x on the left of the inequality. I'm going to show you a workaround here, that if you keep your x's positive by adding 3x to this side and adding 3x to this side, you then get 5x there, and you're going to subtract 7 here, subtract 7 there, and this will give you a negative 3 on this side. So now when you solve for x, a positive x, you're going to divide both sides by 5 here, and you then get x, and then reading it now from right to left, is greater than or equal to a negative 3/5. Now notice if we do that down here, they did it the other way in our textbook. We're going to have to divide now by a negative 5. And to keep this true now, I have to reverse the direction of my inequality sign. And on this side now I get a positive x is greater or equal to a negative 3/5. And notice that's the same thing I got doing it this way by keeping my variable positive. Now for some students it's difficult to do it this way. I would always convert this back to x, and then the open end is toward the x, and you get exactly the same thing. Now notice by moving this negative term to the other side, you are reversing, in a sense, the inequality, which is what we show here and what we needed to do here. We had to reverse that. Okay, so there's our graph. The number we're interested in is this, but notice now it's greater than or equal to this. So again, in the past, when that was true, we would put a solid dot there, and the greater than part is to the right, and that would be the graph. Well, here, instead of a solid dot, to indicate that this value is included in your inequality, we use a bracket at this point. So when we convert that to interval notation, right from the graph, we use a bracket, negative 3/5, comma, and this goes to positive infinity. Now, students sometimes wonder, well, which direction do I put the arrow, the thickened line? Well, a colleague mentioned, and I see this as well, that if you follow the point of your inequality sign, that is the direction of your arrow. So if it were like this, for the same thing, the arrow would have gone to the left. In example 3, this is a little different than what we've had so far. This is called a compound inequality, where there's two inequality symbols in the expression. And of course what we want to do is to isolate the m in the middle. So the first thing is we want to get rid of the 5, and the way we do it is we subtract 5 from there, we subtract 5 from there, and we subtract 5 from there. We then get 7, a negative 7, is less than 3m, is less than 15. And now to isolate the m, what we do is we divide by the numerical coefficient of m, which is 3, and we get then negative 7/3 is less than m is less than 5. Now, since we only have a less than sign, on our graph we're going to use a parenthesis, and then this is the graphical representation of our values that satisfy this inequality. And putting it in interval notation, taking it right from the graph, parenthesis to indicate that the negative 7/3 is not included in the set, and then going up to just before 5, and that's not included as well. In example 4, they're going to feature the conversion formula of Fahrenheit to Celsius, and they're saying our Fahrenheit temperatures are 32, and our Fahrenheit is 77 on this end. And we're going to put the conversion, because we want to find out what C is, right in there. So they've set it up and we've set it up. And again, you want to isolate the Celsius left that out by isolating it, and we're going to subtract 32 here, subtract 32 there, and subtract 32 there. Well, this then gives us a 0 is less than 9/5 C is less than 45. Now, what we can do to get rid of our 9/5, we can take the reciprocal of 9/5. That's what they're doing. There's another way to do it also, but we'll just follow what they have. So 5/9, 5/9, and we're multiplying here, and multiplying 5/9. Now here, this is just going to be 0. This now all cancels out, and you end up with C. And here, 9 goes into there once, 9 goes into there 5 times, and there is our answer. So the range, 32 Fahrenheit to 77 Fahrenheit, is 0 Celsius to 25 Celsius. In example 5, we're going back to reflect on cost revenue and cost and revenue. And they give us these values of cost and revenue. And they're wondering, solve the inequality. When will the company break even or make a profit on the product? So we just set it up like they show. We take our revenue, which is 70x, is greater than or equal to 20x plus 1,000. We're going to subtract 20x from both sides, and we get 50x. Divide both sides by 50, and we get x is greater than or equal to 20. So our answer statement, a company must produce and sell 20 items to break even, and then more than 20 items to make a profit. This one is very similar. They're going to produce a bag of pretzels that sells for this, and it costs 25 cents per bag to make, and general manufacturing cost $110,000. How many bags of pretzels need to be sold in order to break even or earn a profit? Well, there's your revenue, 35 cents for each bag, and then cost, fixed costs, and your variable cost. And we have this relationship that revenue must increase beyond cost to make a break-even and profit. So we end up with this solving. We would need to sell 1,110,000 bags to break even, and then just one more to make a profit. So very similar to the one we've just done. Again, we were using cost function and revenue function. They're just giving this in the standard form without putting it in function form. In example 7, now we're going into inequalities that involve absolute values. Now there is a protocol to do these, and I'll go over that right now. So if your example is absolute value of x is less than 5, remember this could have been a negative value in here as well. So as we did before, we will write it without the absolute signs. X is less than 5. And then we're going to write and. What we do is we reverse this sign from less than to greater than, and then take the opposite sign of what we have there, a negative 5. So this is the protocol for doing these. X is less than 5 and x is greater than negative 5. Now when we graph that, which is what I'm assuming they'll ask you to do, is x is less than 5. We're going to put a number line, and of course our values that we're interested in, a negative 5 and a 5, and less than 5 would be a parenthesis then, and your line going in this direction. And this one now, x is greater than, parenthesis going in this direction, and we fill it in like so. So there's the graph. And another way to think of this then was that -5 is, and then x in the middle here, and a +5, and we've done some like this. So whenever the inequality of an absolute value is less than, it's going to end up in this shape. And another word we might introduce into our vocabulary, this is what we call a conjunction. Conjunction, where the items are darkened in between something. Later we'll see a disjunction, where there's a space between them, and you'll see that when the signs are reversed. We're getting ahead of ourselves. And we already know the interval notation would come right from the graph. So there's the one we've just finished. Now in letter B, this is the inequality symbol is reversed, it's greater than. So again, in solving this, you would go x is greater than 5, or x is less than -5. So when you make your graph of this, we have a -5 and a +5. X is greater than 5 would be parentheses going this way. X is less than -5 would be parentheses going this way. And you see you have that space between them. So this is a basic thing to keep in mind. When its absolute value is less than something, you get a conjunction. When the absolute value is greater than something, you get a disjunction. And this is written in interval notation, coming from -infinity up to -5, parenthesis. Now there's this space. They're using the word or. Often we'll use the symbol for union, and then starting on this end, 5, comma, +infinity. Okay, they're going to give us a summary here in just a moment. And we see it here. All right, going on to example 8. Noticing the inequality sign that they give us helps us out a little bit. This is less than, so this is going to be a conjunction, and you can write it this way. Conjunctions can be written this way. We're going to add 2 to both sides, and we've solved for x. And there's our graph, and of course putting that in interval notation, -3, 7. Now let's look at example 9. Now in example 9 we want to isolate our absolute value. So we're going to transpose that to the other side where it becomes a +1 and a 5. Now again, notice the inequality sign. This is going to be a disjunction. So the absolute value of this equals that. or the absolute value of this taken out of the absolute signs, we reverse. In this case, they're putting it over here. We're reversing the inequality sign, and then -5. So we solve each of these by, in this case, subtracting 2 from both sides. This gives us this. Now dividing by a -7. Notice what's happening here. They're taking our inequality sign now and reversing it. Okay. And then here also, dividing after they've subtracted 2 from both sides. Dividing by a -7. And this side becomes a -3/7, but they're reversing the inequality sign to keep the statement true. So when they do the graph of this, there are the numbers you're interested in. This is a disjunction. And then an interval notation from -infinity up to this point. And again, they're using the word or, and we sometimes see the union symbol between these and then the other, starting at just beyond 1. 1's not included because of the parenthesis, and then going to positive infinity. Now infinity always has a parenthesis, but number values, if they're included, have a bracket. If they're not included, have a parenthesis. Now for example 10, they sort of slipped this in there, and there's not a lot of information here in our textbook. But if you have an absolute value is greater or equal to a negative value, that it's greater than or equal to this, this includes then all real numbers. So this would be the graph of it would be a solid line in both directions. An interval notation would be -infinity to positive infinity. Now, if the inequality sign is less than or equal to a negative value, absolute values can never be less than a negative value. So in this case, there is no solution, and this is what they're describing there. And they're highlighting the direction of our inequality sign. So this would have been a conjunction. This is our disjunction sign. And here they're saying there cannot be numbers less than 8, a -8, that make this statement true. All right, you'll have your practice, and I guess we're getting ready for a test on Chapter 2.